So now we got some clothes, we probably put some sculpting into it. It's time to start applying this to creating our low poly version of the character, which is the version we can texture and the version that we can actually pose. So baking sounds complicated and it's a little hard to wrap your head around at first, but the basic level of it is we're taking all of the information from our high poly that's having lots of polygons, tons of verts, all of the little things, stuff that's going to really slow down your computer, and we use texture maps to transfer it to the low poly. Think about the same way that we can color individual shapes by giving them different materials, but if we use texture maps like we have been using to paint things like our treasure chest and our building pieces and our plants, we can actually get that information onto the surface of it by using our UV unwraps and our UV maps. It's a very similar process to like how we did alpha channels when we were working on plants. We can use this information to convey how light should reflect on the surface, and thus we can make a really low poly object look like a really high poly one. When we're baking, what we're trying to do is take details from the high poly model and put onto the low poly one. We never need to unwrap our high polygon model, and we may want to make sure that the high and low polygon models are in relatively the same space and sort of overlap with each other. The way I like to think about it is their silhouettes should be identical to each other. It's just one has a lot more surface information, the high poly, that we transfer to the low one. And that is going to let us use the computer to bake, as we call it, those maps. We call it baking because we're literally infusing it into the maps. It's just a term we use. I think it's also used because, like baking or cooking, we put it into an oven and it takes a couple minutes, and then we get what we get at the end. And if we don't like it, we have to change the process and re-bake it, so to speak. So when we bake, what's actually happening is there's 3 different meshes being used, 2 of which usually we'll create. Our low poly mesh is the one we're going to unwrap. This has fewer verts, usually it's in quads, it's very simple, and it captures the overall shape of the object. The high poly is going to be something that we maybe sculpted, maybe something we use a subdivision surface modifier on it to give it more edges. It's going to have a lot of detail. And they overlap with each other. So in this example, this sort of wavy line would maybe represent my high polygon model. So it's got this waviness, this higher detail, whereas the green line represents our low polygon model. We're taking this third object, which in our case, the baking program is going to make for us by duplicating our low poly and turning it into what's called the cage. We call this a cage because just like a cage, the baking happens within it. And so it's a question of how far it goes. So this becomes the outside, and then there's an inner cage that also creates as the inside, and it says, hey, only capture in this area. We do this because in order to actually do this baking process, it's going to shoot little beams almost of light. And so it goes in here and it says, where does it hit, bounce off, and it's going to try to recreate on this low poly surface. But we don't want these beams to go forever because that takes a longer time to calculate. It's very wasteful. And in fact, you don't want something, for instance, to go through here and then bounce off the backside and give us weird information. So here's another diagram of kind of how it is. It's like we're taking a camera and we're taking a photo of what we see from the low poly interacting with the high poly. And like I said, they usually are right over top of each other. But I'm going to show you a quick demo. So there's a bunch of programs we can use. Marmoset is considered by most people to probably be the strongest or best, easiest to use baker. It's an expensive program though. Blender does have built-in baking. There's actually an older free program called XNormal that a lot of professionals really swear by. We're going to be using Substance Painter because I think although it's not as good of a baker in my opinion as Marmoset, and it's also not as free as something like Blender. It's free for students, and I think it's the easiest to use baker out there, and it's the fastest one because you get to bake and then paint right into the program. Blender has baking and it's fine, but it's pretty complicated and it's hard to set up. Marmoset has really good baking, also very complicated, but it's also a very expensive program. So we're going to be baking lots of information onto these maps, and some of these are just for texturing, and some of these are to actually give us our details. So think back to like when we did our rocks. The most important map that we're going to bake is called the normal map. And the normal map is, we've talked about like what a normal is and the deflection of light. Basically, it's, imagine you took a sphere, like this sphere here, and you shone a light the red light on the right side of it, and you've shown a green light from the top and a blue light straight at it. This is what would give you the outline of a sphere, because the red light's over here, and the lack of red light being in shadow from red means it doesn't have as much red. And same, the green light coming down from the top means there's a lack of green light down at the bottom. This is basically what normal map baking is. It's why it's this color, and you can see the little green edges on things are things that face up, and the little red edges on things are things to face in the right. Remember, we usually use R, G, and B to correspond to X, Y, and Z. So red for our X axis and green for our Y axis, and then blue for our Z axis. So that's why it's kind of got this weird purplish color, is this is actually blue combined with about 50% red and 50% green, which is what gives this color, which is why the bluest part is down in this lower left-hand corner, because it's the least red, the least green, and it's still blue because it's going straight back to us. So this is what it's able to do. Now it takes this map and it takes this information and it basically just changes the angle. Instead of light reflecting straight off, it's going to take the light and bend it. Bend it in the direction that it should be deflected if it had that shape. It's a little bit weird. You have to bake a couple times to really get used to it, but this is basically what it's doing. It's using this color information to change the way light is bent on the surface, which is how we can take all of that high poly detail and put it on a lower polygon object. We're also going to bake the ambient occlusion map. Ambient occlusion is, the term ambient means everywhere, and occlusion means obstructing. If you look in the corner of your room right now, you'll probably notice the corners of your wall have a little dark highlight running across it. That's because some areas, especially when 2 points come into contact, no matter how much light you shine into the corner of your room, there's going to be a small little shadow there. Sometimes these are called contact shadows. We usually refer to this as ambient occlusion, meaning no matter how much light gets shown on it, there's going to be a shadow because these two objects are contacting each other and they're going to obstruct most of the light. This is what this bakes. It's really good for finding those little edges and picking things out. And in fact, if you're drawing or illustrating like a person, these are the lines you're drawing, are like represent ambient occlusion on a surface. This is going to be a black and white map, and we're going to use it in our final product. Now, there's also other normal maps that get baked. One is called an object space normal map. It's very similar to a regular normal map, but instead of what we call the regular normal map, which is also called a tangent normal map, this one is distinguishing up, down, and left and right is what it really cares about. So when you bake this, one side of the object will be red, the top of the object will be green, and the front of the object will be blue. It's sort of sometimes like it's object or world space normal. It knows where it is relative to the world, whereas a regular normal map is more concerned with what's happening on the surface. We also have the curvature map, and the curvature map is sort of the opposite in a lot of ways of our ambient occlusion map. It highlights in white areas that are turned outside, and it puts in black areas that are inset. And so this helps find the concave and convex areas, and then in gray it renders anything flat. This is mostly used for generators, so that when, for instance, you were making your rocks, they use this map to help find where those edges are by being able to bake it, and that's what lets us get little cool edge details on things. Position map is going to be like a world. Sometimes this is called a world normal map. Very similar. It's just up, down, left, right. Where is it in the world? And the last being an ID map, something you may or may not use, but it's just a way that we can color objects using materials and do some quick shading of things inside of Painter, but I don't think we're really going to use that in this class. So I want to do here a quick bake demo while I still have you in here, and I want to show you the two objects I've got. I'm going to apply all these modifiers to this because I have two objects. This one is going to be high, and this one will be low. And I want to show you how this is going to work. We have the high polygon object, and look at all of the detail. This has got 31,000 vertices, and this one has 8. The most important thing is that they sit both at all zeros and all ones, and they are immediately over to each other. So I want to put both of these on top of each other. So let's export our low polygon object, throw it in our folder for this week, week 6. And I'm going to call this low, make sure I have on select objects because I don't want everything. The rest of these should be fine. Let's export that. Let's do the same thing with high. I'm just gonna call it high. And selected objects and export. And then let's pull up and create a new file. Pretty simple, and the most important thing, another thing to note, is that, and actually I'm gonna rebake this because I wanna fix up the UVs. This is the UVs on the low object, and this is the UVs on the high object. UVs on the high object don't matter. I don't need to unwrap it. I only need to unwrap the low. The problem with the UVs on the low is they're really edged into each other. Kind of a rule is we want to seam anywhere there's a sharp 90-degree angle, and we want to keep the other parts together. So I'm gonna mark a seam. I'm gonna unwrap them, but now I got a problem where they're all too close together. They overlap on top of each other. I need a little bit more space. So I'm gonna set to 0.01. I need enough space because the bake goes a little far out. It spills out a little bit. And if they spill onto each other, it can mix and create some pretty bad seams. So we want to avoid that. So let's re-export that low because that's what I want here. And like I said, I made a pretty simple shape, but I just want to convey how much we can make it look exactly the same. So new, and let's select the model from this week. Let's go with our low model, keep everything else exactly the same. It's just fine. Give it a second, and oh, did I upload the wrong one? Because this is my high poly. Let me make sure. If I want to change the model, I can go edit project configuration. Oh, it says low. I put the wrong one in low. Okay. Be careful with that. I guess I had the wrong one selected. So let's go here, re-overdo low, and then let's make sure we've got high here. I'm gonna export that as high, just to be safe. So let's reselect this, reload it. Okay, there we go. That's more what I'm looking for. So once I have this, now I can go to my texture set settings, just like we do with our rocks, go to bake maps, and I like to start by turning all of them off and just do my normal because it's the easiest one to bake. Do it at 1024, and let's turn on add our high to things. These are the frontal and rear distances. That's that cage distance. And we can make a custom if we want. It's a little bit more advanced, but if you're, for instance, losing parts of your model or detail, make sure things line up and that it bakes, because I want to show you a couple ways this can go wrong. I'm going to bake it once correctly, though. So let's bake this texture, and you can see, hey, look at that. It did it. Now, it looks pretty good, but you can see there's some stuff that when you get really on the side, you can tell it's not exactly, this is as far as the normal map can get us. From here, it looks exactly right. And as we start to get here, things start to look a little weird. Let's go back to our bake and let's change up some of these distances. So this rear distance, I'm gonna make max rear distance a lot smaller, and let's bake it and see what happens. Look at that, we didn't really get much of anything. It's kind of there, but not much. It's because our rear distance isn't far enough. So 0.001, let's see what happens here. Now we can see it's still there, but it's actually clipping off because it's not able to shoot far enough into the model. Let's go back to our bake and let's set it to 0.1, a lot higher. Bake selected, and now you can see it's going all the way to the end because it's able to shoot those lines in far enough. Let's make some changes to our high poly, and I'll show you too when we're looking at our high poly object. So let's hide our low. What if these don't line up with each other too? Let's go ahead and do that. I'm gonna take my high, I'm gonna just move it to here, and I'm gonna re-export it, change it to high, do my export, and let's see what happens when these don't line up. Bake mesh map, I'm gonna remove and reload this model so you can see what happens. Set these back here, bake selected settings, and we can see this kind of thing happens because they're not lining up with each other. They need to. If they don't, they get really screwy. Let's go ahead and set this back, and I want to show you too what happens if our UVs aren't in the right spot. So get my high, fix that, and let's affect our UVs. And this time I'm gonna unwrap my UVs, but I'm not gonna give them any margin. They're going to be sitting right on top of each other. So let's do low, Control E, export my low, back to this. And of course I have to reload that file. File project, because I made changes to my low. Because I'm making changes, it's just going to change it. Let's delete this, bake mesh maps, reload my high poly. Now let's see what happens. Okay, so it seemed to mostly work, but you see how we're getting like a really sharp seam here. We're getting that sharp seam because there's not enough space in between the map. So we get these really sharp edges because we need more space in between them because they're baking over top of each other now. That's why that margin is so important. So it's all kind of these things together. We need the low poly, it needs to be simple enough, and it needs to be able to be baked with enough space in its UVs. We need the high poly, they both need to have basically the same shape, because if they don't, things are going to start clipping off. So like, you know, I can really do something like this. Let me take my high poly, and if I take a couple shapes like so, even just these, let's just extrude them straight out and see what happens if I try to bake this as my high. Go back to my low. I'm really messing stuff up here, but that's kind of how you figure it out. I find that's why I always bake just this one map at a time, because it's sort of the iterative process of making sure that I am able to do things how I want them. So bake, select the textures, and we can see right here, that's the kind of clipping that happens when a shape doesn't really fit inside because it's shooting all the way out and it's trying to capture it. So we generally want things to fit each other's shape and be on top of each other. So in the next video, I'm going to show you how we can clean up our sculpted object and make a low poly one, especially if we've been working along the way I've been showing you. And then after that, we'll do our bake so that we're ready to texture.